Hi guys, I don't know what happened with the last video. I kept on going, but for some reason when I transferred it over to YouTube, only about half the video showed up. So I believe I'm picking up right about where I left off on part 2. I believe we are about to start here in figuring out what trig function we should use and why we should use that. So if I put my finger here on A and I go across from it or opposite of it, I'm going to write OPP on that leg because that leg would be the opposite leg. But if you notice, there is no information there. Sometimes people say there's no information here, but I'm trying to find x. So if I'm trying to find x, I want that side. This side I know. Once again, that side is the hypotenuse. And so that leaves one side left, or if you think about it, if you look right next to A, that is adjacent. And so I need to use the trig function that has adjacent and hypotenuse. And again, if you look over here at my paper, adjacent and hypotenuse would be cosine. So we're going to write down cosine. I'm going to write it down first just blank. Cosine of theta equals adjacent over hypotenuse. All right, just to remind us all that that's where it's supposed to come from. Please remember that theta stands for the angle, and then I fill in all the values that I have. So my angle is 32 degrees. The adjacent side is my unknown side, so x. And the hypotenuse is the side that has a value of 74.5. Now, I know during class I would probably say this as well, but it looks like we have the cosine of 32 degrees equals x over 74.5. But sometimes I yell at you when you say over 74.5 because when we say over, we don't really know what mathematical operation we are using. So a better way to read that would be x divided by 74.5. To get rid of divided by 74.5, we have to multiply both sides by 74.5. Now, again, at this point, you want to make sure that your calculator is for sure in degree mode, because if you don't have it in degree mode, it will have it be wrong. So if we look at our calculator here, we know this one is in degree mode because if you can see right about here at the bottom, it says DEG. If you are using Desmos, click on the little wrench in the upper right-hand corner. There's the two options down at the bottom. It says either radians, which it automatically measures in, so you've got to do this first if you're using that, or degrees. Please click on degrees so that it switches over. And on this calculator and on Desmos, you don't even have to hit the multiplication symbol. If you just type in 74.5 cosine of 32. And honestly, you don't even have to hit the closed parentheses. I don't know how well you can see that. I think you kind of can, and the reflection is kind of weird on my camera. But then just go ahead and hit the equals button. It thinks a little bit, and it looks like our answer is right there. Please round to the tens place. So I'm going to write x approximately equals 63.2. If you are not getting that on your calculator, you really do need to email me or contact me through Hangout or whatever chance we get to use in the next few days. But I hope that for example 1, you got an answer of 63.2. All right, so I'm going to change up kind of how we're given the examples and what the examples look like. So here is example 2. Once again, go ahead and hit pause to make the copy, but I'm going to proceed on. If you notice, there are 3 angles of a triangle. They equal 180 degrees. That makes sense. But that means on this one, we could decide what one we want to use. I usually like having an unknown in the numerator rather than the denominator. We are going to do an example next where the unknown has to be in the denominator so we can cover that and it's not going to be a big deal. But if we go opposite of 40 degrees, that's where y is. I think we'd like to make y in the numerator, so therefore we're going to pretend that 40 is the most important angle here. And so I'm going to put a box around E and put a star next to E. If that's the case, I'm going to go across from that, and that is opposite. Always go across from the right angle. That's the hypotenuse, but you know what? We don't know any information on the hypotenuse. We're not trying to find any information on the hypotenuse. So I'm going to cross that out, and then I'm going to grab this board again, and I'm going to say, hey guys, what fraction does not have hypotenuse in it, and therefore is probably the important one we want to use, tangent. So we're going to use tangent for this example. And remember, we put a box around E because E was the angle I was using. So tangent of E equals opposite over adjacent. Again, looking at your triangle, if we put our finger on E and draw our way across, opposite is Y. And adjacent would be this 36.8 value. And what angle did we pick again? Angle E, which has a measure of 40 degrees. And so if you see my work right here, I was picking tangent of angle E, opposite over adjacent, and then I filled in the correct values. Once again, because you see Y divided by 36.8, what are we going to do to solve this problem? Thank you, you're right. Multiply both sides by 36.8. And once again, I'm using this calculator right here just so we can see it. If I type in 36.8 tangent of 40 and hit enter, my calculator is telling me 30.87. That 7 would mean that I should round up, and Y is approximately going to equal 30.9. All right, so I hope that we are getting this. Once again, to kind of practice on your own right now, if you would please open up the one that talks about on your own examples. You're going to do on your own example number 1. So please hit pause and work on your own example number 1. All right, well, thank you for coming back and working on that. I want to check kind of how you're doing. So that is going to be what you put as your third point in your email to me to show me that you are working today and working on what you're supposed to be working on. So again, I'll go over that at the end, but if you go to your email that you're sending me and put that answer in number 3, that is the third part of participation points for today. I'm going to do one more example. Here you go again. Go ahead and hit pause if you need to. This says example 4 because example 3 was the one you just worked on your own. So there is example 4. Thank you for copying it down. And let's look at what we have to do here. Oh, excuse me, because I copied this. I'm really glad I have the other paper here. This was a mistake in transfer. Excuse me. Would you please, once again, put a 48 degrees down here in angle J. Sorry about that. Between the redoing of the work, I forgot to copy down 48 degrees. That's very, very important. So it looks like angle J is the angle that I have to work off of. And depending on how people do this first, some people start here and go across from that right angle. Of course, across from the right angle is always called the hypotenuse. So we have that hypotenuse right there. If I start down here on J, if I go opposite of it, there is nothing on there. So I'm not going to write the word opposite. I'm going to go right next to it. Next to means adjacent. Thank you. So I'm going to write adjacent right there next to that, which means the two legs that I have this time are adjacent and hypotenuse. Once again, if I pull this up over here, what fraction has adjacent and hypotenuse? Thank you. Cosine. And so I have to pick cosine of my angle in order to do that. Now, I am going to write the numbers in right away. So this time I'm going to write cosine of 48 degrees equals 14.7 divided by z. Now, people always run into trouble when they work on this one because they think they have to divide by the 14.7 to get rid of it. But really, that doesn't get rid of the z in the denominator. So I'm going to get rid of the z in the denominator first, and I'm going to multiply both sides by z. Guys, if you follow along right now, I'm going to show you a shortcut in a quick second after we get that done. So I crossed out that z on that side. I now have z times the cosine of 48 degrees. But remember, if you pick up a calculator and would type in cosine of 48 degrees, it would give you some value, some number. So how would I get rid of z times some number? I've got to get rid of that number. So I'm going to divide both sides by cosine of 48. And then my cosine of 48 will cancel out. And so z will equal 14.7 over cosine of 48 degrees. Now I'm going to rewrite something because all of my work kind of jumbled it up. If you look back at the beginning, we actually started out with cosine of 48 degrees equals 14.7 over z. But when I did my math and rearranged it, my answer is z equals 14.7 over cosine of 48 degrees. If you look at this top one and this bottom one, you will notice that 14.7 both times is in the numerator. It's just what was on the one side of the equal sign by itself and what was in the denominator switched spots. That's all you really have to do. You do not always have to show this step or two in between. If your unknown is in the denominator, you just swap spots with the other side. So please be careful when you type this in the calculator that the cosine of 48 degrees is fully in the denominator. On your iPhones, you have to be a little bit careful how you enter this in. That's why I'm always typing it in and showing you the answer and hopefully trying to have it so that there is no glare. This is a really interesting answer because we get 21.96. Guess what that 21.96, the 6 makes the 9 become a 0, but that means my 21 has to become a 22. So z is approximately going to equal 22.0. The only reason we write that 0.0 is because we did round it, and therefore we want to know that that is the case. I would like to tell you that no matter what you do, if you are solving a trig function and the unknown is in the denominator, you will always do that little swap thing. So let's say we had the sine of 39 degrees was equal to 18.3 divided by x. Notice a trig function equals a number divided by an unknown. The more and more we do this, guys, the more and more you will see me just draw a little swoop arrow like that, and that literally means swap those two spots. And so we're going to get x equals 18.3 over sine of 39 degrees. And that's what you would type in your calculator. So that completes our lesson for today. Sorry it had to get broken up into two parts because for some reason something went wrong. But please know that when the ratio gives you the unknown in the numerator, you multiply. When the unknown is in the denominator, you're going to do that little swap thing I just showed you right here. If the unknown is in the denominator, do the little swap and divide to make sure to find the answer. Okay. I encourage you to try number 2 on the try it by yourself, example by me, but it is not required for you to do that or email it to me. So our video is almost over, but there's one thing I want to remind you of. There are 3 things you need to include in your email that is has a subject of March 17th. First, do you have a notebook and do you have all the materials that you need, yes or no? And is there anything I could do to help you out? Number 2, do you have 3 different initials that instead of just going through the alphabet and doing ABC, triangle ABC, triangle DEF, could I use your initials? For example, maybe you could send triangle DPJ. See if anybody can figure out what that one's for. And then the third thing you need to include is what answer you got when you tried example number 3. Thank you guys. I hope you have a good day and sorry that it got split into 2 videos. Hopefully that won't happen again. Thanks. Bye.